Hello my dears and welcome to a new video. In this video we're going to do this. We're going to have the balls, the spheres, when they hit the cubes, they're going to play a portion of an audio file. So we divide an audio file by 40 different little portions. And then when a sphere hits a cube, it plays the portion of audio assigned to that cube. So I hope you like the idea, and without any further ado, let's jump into the video. Have fun! So here's the patch as we left it last time, and the first thing I want to do is a little improvement suggested to me by my buddy Timo, which basically in the regexp it can be done much easier in Max. If we just write the symbol we want to replace, we want to check for, and then we say substitute %0. Now this will give us, from this first outlet, will give us the number part of the string that we are basically checking for. So that's kind of neater and simpler to understand and simpler to write. So thank you very much, Timo, for this tip. So what we want to have is an audio file, which we will play by assigning to each cube a portion of that audio file. So we have 40 cubes, and we're going to divide this audio file in 40 parts. We are not really going to divide it, we're simply going to read, each cube is going to be assigned to a different part of that audio file. So first thing we need is definitely a buffer object, because we need to store an audio file, and let's give it a name. I will just call it like path01. Maybe we have another one then later for some other reason. And I will just going to assign it as a file, the drum loop, which comes with the max. I think it's written like that. No, which is actually written like that. Good. Then we want to know how long is this audio file. So we're going to use the object info, which will give us information on that buffer, which we need to give it the name of that buffer, which is path01. When we change audio file, this is going to send a bang. The buffer object is going to send a bang from the right outlet. So we can use this bang to trigger the info object to give us the duration of the audio file, which comes out from the third outlet from the right. But if we want to get this information without changing the audio file, we have to simply just send it a bang. Let's actually attach it a load bang. Cool. So that's the duration of the buffer of our audio file. We want to divide these in 40 parts because we got 40 cubes, and each cube is going to play a different part of that file. So we're going to divide these by 40. The duration of the file is going to be divided by 40. And check how much we get as a 14th of the duration of the sound. 86 milliseconds. So it's almost gonna sound like granular synthesis. And then we want to read this buffer using an MC.play object. So why MC? Because we want to play several voices at the same time, because the cubes can play at the same time. So we need an MC object, because we can just have a lot of channels, as many channels as we want. In fact, we're going to have 40 channels without having to create 40 different objects. That's the beauty of MC. And we need to tell it which buffer it has to play, which is path01 as we called it. We don't want it to loop. I don't know if loop is on by default, but let's just set it manually to 0. Good. So the MC.play works like this. It takes a message which is start, the start time, the end time, and the duration, so how much time it should take to read that portion. So now the start time is going to be the collision cube, so the index of our cube that is currently colliding. So we can take this sender here, and this is giving us a number between 0 and 39. So we use this index, we multiply this index by this 14th of the audio file, right? And this is going to be our start moment in the audio file. So let's create a pack object and create this list. So the start time, let's make it a float, the end time, and the duration. So now this is going to be our start time. This is going to be the duration, because we want to read this portion of the buffer at its normal speed, normal pitch. So we are simply going to use this as the duration, and the end part is simply going to be then the start time plus the duration. So this is going to be our end time. Now let's make it all neat with some trigger objects, so we know exactly which stuff is happening first and which stuff is happening later. So this goes first here and then goes there, and then actually we want to trigger this pack object, so we can add a bang here. Good, and also let's create a trigger FFF here. So the first F is going to be here, the first float, the second float is going to be there, the third float is going to go there. Good. So now we created our start message for the MC.play object. So let's actually do like this. Let's take all this stuff and put it inside a subpatcher. Let's call it audio. Good, so we have a bit more place. So I'm gonna load bang that again. So I get the duration. Okay, so we can do that in several ways. We could use a MC voice allocator, but for the moment I actually would like to try another technique. I would like to use the index of the cube as the voice index, instead of just using the voice allocator. So we will need to take care a bit of not getting the voices to be stolen. So this will create some clicks, because the audio will just stop in the middle, and then will start another sound, and then the same voice will play a new sound. So yeah, we have to take care of that probably with a line object and creating a little envelope. Yeah, we will see. So what we want to do is to get this index of the collision. It's going to be also the target for our MC. So let's create a trigger, and we first send it to an MC target object as the index to which we want the voice we want to write to, and then to this voice we want to send this message, right? And this is going to go to the MC.play. Right, so let's connect the whole thing to an MC mixdown object to get it all stereo. And yeah, that's gonna be it. Then let's unpack it with mc.unpack 2 channels, and we're going to unpack that into live gain, I guess. So live.gain, left, right, and we're going to send this to an easy duck object, get our audio output, and let's see how it sounds. Okay, so it's working already. As you can hear, it's working already. The balls are bouncing on the cubes, which then are playing a different part of the audio file. Let's actually use an MC meter to check how the voices are being used. We're going to connect this here. That's looking good. Let's try to make the circle of cubes go a bit faster. So let's go inside this cube circle, a subpatch. Let's actually create an inlet here for the speed. Touch it here. And create a message here, speed, so we remember what that is about. Change the speed of the rotation to, I don't know, 2 for example, 1. Yeah. Okay, so that's kind of funny, but I believe we are getting some problems here because the voices are overlapping with each other. So when the ball jump on the same cube, when 2 balls jump on the same cube, they will just make the sound click, because it's just going to start a new sound and override the one that is already playing. So what we want to do, I think, is to use an envelope to fix that. So we can do like this. We can create an MC line, also with 40 channels. And we are going to use the same target for that. Let's actually create a trigger. Ear. Okay, we could just expand the eyes here, but for some reason I want to create a new trigger. And to that thing, we first say, okay, go first to 0. Whatever is happening, go first to 0 in some milliseconds, so it will stop the sound, and then go back to 1 in some other milliseconds, and then and so we should avoid having clicks. So let's create this list. Let's maybe sprint of it. So sprint, we want to say go in to 0 in 10 milliseconds. And then You go to 1 in 10 milliseconds. You stay at 1 for whatever time we said would be the duration of our audio file, but minus all these milliseconds that we are subtracting. So stay at 1 for that amount of time, and then go to 0 in also 10 milliseconds. So from our duration, we have to subtract 10, 20, 30 milliseconds, because these milliseconds we are using for the fade in and fade out. So let's do that. Let's subtract 30 milliseconds. Let's connect this to sprintf. Let's see if I sprintf it correctly. If I say that. Okay, yeah, this looks good. This looks good. So we send then this message to the MC line, actually to an MC target, which takes, oh, in fact, what the hell have I done? I should not have connected this here. This is connected to the MC target. Let me recreate the object to reset it. Don't know why I connected it there. So these list we have to send to the MC target every time we get a new collision. So every time we get a new sound. So every time we send a new list to the MCPlay. So we want to do like this. We want to send first the list to the MC target, I guess. No, first I guess we want to send the bang to the sprint, and then we want to send the list to the MC target. Okay, so then we want to multiply our audio output by our envelope. In order to apply the envelope with an MC multiplier, should I tell it that he has 40 channels? I guess so. So, although I think it automatically knows. So let's do like this, and then connect this to that. And see what's going on. Ooh. Okay, let's see what's coming out of here. Oh, okay. I think my sprint is incorrect. The list I'm sending to the MC line is incorrect. Okay, instead of using the sprint, let's just use a message, since the sprint doesn't seem to really want to collaborate. So let's go to 0 in 10 milliseconds. Then let's go to 1 in 10 milliseconds. So let's stay at 1 for $1, the duration of our 14th of the file, and then go to 0 in 10 milliseconds. Let's give it the duration. And it keeps on distorting. So go to 1 in 10 milliseconds, stay at 1 in $1, go to 0 in 10. Okay. Sometimes it does this crazy thing where all the voices fire up. Not sure why that's the case. I'm not super expert with MC, unfortunately. So let's actually go with the voice allocator route. So let's get rid of that. Let's get rid of these, actually. And let's just create a voice allocator object. So mc.voiceAllocator that have 40 voices and still 0. We don't want to override voices that are already playing. We only want to write to a new voice if it's empty. So we say still 0. This we don't need. So we're going to put this here. And we're going to feed it with the sound, the audio coming from this MC multiplier. So it will know when voices are free or not. And then we connect this here. So this will now give the target to these two objects, to these two MC target objects. We'll give the index of the voice. So let's see if this now works. And it's not playing anymore. Why is that? What's coming out of here? Let me reset this object. Okay. Okay, it seems the voices are never freed. So why is that the case? What's coming out? Because this list, I think it's never banged. Okay, silly me. So that was the problem. So let's bang it. So let's create a trigger, bang list, or first the bang and then the list. And we will attach it where it was before. So here, we need to bang this list. And let's give it a go. I'm going to recreate this object. Okay, so now it knows that there are some voices that are busy, some voices are free. And it's not doing this crazy distortion anymore that it was doing before without the voice allocator. So good to know, we got and used the voice allocator. Nice. Okay, so it's working. And the bodies are the balls are playing a different portion of the file depending on the cube which they are on. Let's make them run faster. Cool. Let's try actually with another audio file. I'm just gonna get something from my library. Interesting. Let's try with some voice files, some human voices. Let's go with the female voice. That's pretty funny. Alright, we will go with that. So, what I want to do now, so the audio part is almost complete. I just want to do the panning part. So the panning we can do with the mix down. So let's create an mc.sig, which also has 14 channels. So we will give a signal to the mix down object for the panning of the single voices. And we're going to do like this. Let's get another MC target, which takes his index from the voice allocator. And to that we're going to send basically the position of the cube at the moment of the collision, which we can get here from this dictionary. If we root position, we should get the position of the collision taking place. There we go. So let's do like this. Let's call it the $1, the X position of that for the panning. And let's send it as the cube. No, collision position. Actually, collision panning or something like that. Let's receive it inside our audio subpatch. Collision panning. So our cube spans from minus 3.5 to 3.5. I just checked the JIT gen here. Goes from 3.5 to minus 3.5. So we need to rescale it. Scale minus 3.5, 3.5 to 0 and 1. So this should now give us a different panning for the different cubes. Let's try, for example, if I throw one of them here. Whoops, it went out. So now it will always impact the floor. Okay. Yeah, I think it's working the panning as well. We can see it mostly from the audio amplitude of the two different channels. Funny. That's cool. Now I want to do this thing. When the audio is finished playing, so when this duration is finished for that single cube, then the cube should go back to its gray color. So at the moment they are just put back to the gray color with the metro, but I want to do it then when the audio stops playing, then that cube goes back to off. So let's do like this. Let's simply use a pipe object, which will delay the whole the cube going off by this amount, the duration that we want to read. And the which cube? Well, this is our index collision of the cube, so we can use this output here. Okay, good. And now we have to send it and call it, for example, index cube off. Right. So let me send it the duration with the bang here. Good. Let's go in our cubes subpatcher and let's delete this part with the Q metro. Good. So this is going to be the index of the cube going off. So this is the index of the cube going on, index collision cube. So let's just say that after this is going on, then it will go off. So let's just set the color for the off cube here. Let's pack this here. And actually this is only banging it every time we set it. We have a collision which works when we want to put them on, but doesn't work when we want to put them off. So we should actually also bang this matrix every time we put a cube off. Good. So now, when the file stops playing, the cube should go back to 0. So let's actually reset this matrix, and let's see if it's working. Yeah, seems to be working. So after the audio file stopped playing its amount of time, then it will just go back to... It will just go back to gray. Cool. One thing we could do is to make maybe the cubes that are playing also bigger. It will be funny, so let's go here. And let's get this index cube off. Let's send it inside our gen patch area where we are setting the scale. So let's create a parameter, say index playing. So no, not the index when the cube goes off, but the cube which is just collided. Let's set it by default to -1. And let's say if cell, so the current coordinate in the matrix is equal to the index, then we're going to send out the bigger scale. Otherwise, we're going to send out the normal scale. So if this is false, we're going to send out the smaller scale. If this is true, we're going to send out a bigger scale. So let's say, for example, not too big, like 25, 25, 25, something like that. Oh, for some reason, all the spheres became silent and they disappeared. Okay, just reset them. Good, so actually we need the index collision cube here. We called this parameter index playing, so prepend index playing. Let's give it a try. Okay, we can see that the cube goes bigger. Oh, but actually we don't want to set it on after. We don't want to set it off as soon as it receives another index, actually, but actually when it receives, it goes off. So actually we cannot do that with a parameter. Sorry about that. We need another matrix as an input. So let's create an input 2, and let's do like this. So we got the index collision and the index cube off. So basically we need to again set the cell 1D, and we will say, okay, this is the index, and this is going to be, if the index collision cube, if it's colliding, is going to trigger a 1. If it's not colliding, so let's actually do it like this with a pack with C. So let's do like this. First we actually trigger a 1 that goes here. This is what we set, and then we set the index, and then we forgot to create a bang. Then we bang this list to go inside a matrix. So let's create a matrix. Actually, one plane is enough. Good. And then if the index cube goes off, we will just set the same index, the same cell of this matrix to 0. So this should work. And then we should actually bang this matrix as well. So we send the list to this matrix and a bang. Let's check it out with a Jitter window. Okay, seems to be working. So now let's send this to the second input of Jitter gen, and here let's maybe switch the first component. It doesn't matter since they are all the same, since the matrix is only one plane. And let's connect this here. Oh, and now they will just become smaller only when they go off, theoretically. Oh yeah, because actually I should not. Wrong thing I've done. I should not do it like that. No, we should actually just use these as the X or the true or false. Yeah, exactly. Now it works. Sorry about the confusion there. Let's again switch just the first. And good. So now they are bigger when they are playing and they have this color. Let's actually give it another color. I don't like that color so much. Let's maybe give it a bit more green. Yeah. Bit less maybe. Yeah, this looks nice. And you know what? I also want them to bloom, to gloom, and so on. So I will create a GGL pass here, which with an fx name bloom HQ. So don't use the bloom, the normal bloom pass. Use the bloom HQ because it's much cooler. It just looks better. It's a new pass. It's a new pass file for GGL pass, and I will set the threshold to, I don't know, 0.9 or something. Ooh, now looks good. Everything is blooming, but actually I want to bloom only the cubes that are highlighted. So I will set the threshold to 1.1. So every number that is greater than 1.1 is going to be highlighted, is going to gloom. So I'm going to go here and actually set this number to like 1.2 for the blue. And there we go. Maybe also 1.1 for the green. And 1.9 for the blue. I guess this should work. Good. Now only the cubes are glowing. Can play a bit around with the colors if you like. Good. Let me actually give it a smaller bloom amount. Otherwise the bloom is a bit too much. So bloom amount like 0.5. Yeah, that looks better. Did we get some errors? No, this was some old stuff. Good. Let's make them go faster. Let's just send them somewhere else. Funny. That's pretty cool. I just want to try a different audio file just for fun. Doesn't seem to be much into that one. Here's our Cherokee file. Maybe go a bit slower. Give a bit more restitution to those spheres. 1.1. Yeah. Now it's better. We could have more spheres, we just need to change the... Ooh. They go a bit crazy after a certain point. But you get the idea, my friends. So this was it for this video. In the next one, I don't know what we're going to do. Maybe go a bit on this patch, maybe start something completely new. Surely we are going to have fun. So if you liked the video, it would be great if you would like it. Put a like to it. This helps the channel to get kind of more visibility on YouTube. You can subscribe to the channel, that would be also great. And you can check my Patreon page where I share patches and videos, and you can join my Discord channel and we can interact and so on. So anyway, thank you very much for following the video, and I will see you in the next one. Have fun. Ciao.